All right, 1.7, solve absolute value, equalities, and inequalities. All right, so first one, decide whether the given number is the solution of the equation. So we're just literally just plugging it in. So number 4, we have the absolute value of d plus 6 is equal to 10. And it wants us to do it for negative 4. So I just plug in negative 4. So the absolute value of negative 4 plus 6. So that's going to be the absolute value of 2, which 2 is not equal to 10, so it's not a solution. I thought it was going to be cloudy all day, and now it's really sunny outside. All right, let's do one more like that. Number 8, the absolute value of 17 minus 8r equals 15, and it wants us to do it for 4 this time. So we're going to plug 4 in. So the absolute value of 17 minus 8 times 4 equals 15. So then that's the absolute value of 17 minus 32. Seventeen minus 32 is negative 15. We take the absolute value of negative, it becomes positive, so 15 equals 15. So this one is a solution. Any questions about those ones? Good. Okay. Now the next one say to solve the equation and graph the solution. I just want you to solve the equation. Don't graph it. Anyways. Number 10. The absolute value of y equals negative 5. So what value of y, when you take the absolute value, will give you negative 5? None. So there's no solution. Let's see. 14. The absolute value of h minus 4 equals 4. So when we take the absolute value of something, okay, the value that's inside could either be positive or negative. And so we're going to actually set this up as 2 separate equations. So we're going to set it up as h minus 4 equals 4. And then the other one is going to be h minus 4 equals negative 4. Because if the inside is equal to 4 or negative 4, then when we take the absolute value, it's going to be equal to 4. So what are my h values, if that's the case? H is equal to 8 or h is equal to 0. So all of these ones, with the exceptions of the ones that have like this, that have like it equal to a negative number, are going to have 2 solutions. I'm going to back up for just a second and look at this one. The absolute value of z is equal to 0. What would this one be? 0. Yeah, I just wanted to make sure we weren't confused with this one. would still have a solution. It would just be 0. All right. These ones still say to solve the equations. They just don't say in the instructions to graph them, but we're not graphing anyways, so it doesn't matter. All right, so 22, the absolute value of 3g plus 14 equals 7. So, again, because I have absolute value, I'm going to set up 2 separate equations and solve for both. So, I'm going to have 3g plus 14 equals 7, or 3g plus 14 equals negative 7. So how do I solve those? Or what do I do with the one on the left, I guess, let's say. Or we can do them simultaneously. Yeah. So 3g equals negative 7. I'm going to go ahead and do the other one too, since you're doing the same thing. 3g equals negative 21. Now what? So g equals negative 7 over 3, or g equals negative 7. Do y'all feel like you need to see another one of this type, or are we okay since it's just, okay. So, the next ones say to solve the equation and check for extraneous solutions. Now, did I mention extraneous solutions in the notes at all?
I know you did, but I think I forgot.
Yeah.
Okay. So, extraneous solutions are basically when you run all the numbers and you do it or whatever, it comes out and it'll tell you that it's a solution, but if you were to actually plug it back into the equation, it would actually give you a false statement. So, this can sometimes happen with absolute value inequalities, but we're going to actually see it with equalities first, because if you have x values inside and outside, sometimes a value will tell you that it works, but when you actually go back and plug it in, it doesn't. So these ones are going to require you to check them still the same way of setting it up so that you have the positive and negative one. Okay, and then you're going to need to check the answer that you get back in the original equation. Okay, so you would check it back in whatever they gave you to start with. If you check it back in what you just solved, I hope it works, because but it's not going to tell you if it's extraneous or not. If it didn't work in that, then you did some math wrong. So it always gets checked in the original. So let's do a couple examples of those. So let's look at 34 first. So 34, we have the absolute value of 3x minus 4 equals x. So how would I set this one up?
Two equations. 3x minus 4 equals x, and 3x minus 4 equals negative x.
So then, to solve this, I need x's on one side, numbers on the other side, so I'm going to move this x to the left and move the 4 over just to try to get positive numbers. So that's going to be 2x is equal to 4. So that one I have x is equal to 2. And then on the other one, I'm going to have 4x is equal to 4, so x is equal to 1. And then I need to do the check part now to make sure that they work. So I'm plugging them back into the original. So the absolute value of 3 times 2 minus 4 equals 2. And I'll go ahead and set up the other one. The absolute value of 3 times 1 minus 4 equals 1. So 6 minus 4, and you don't have to like write out every single step when you do these, but 6 minus 4 is 2, so the absolute value of 2 is equal to 2. So that one works. The other one, we have 3 minus 4, so that's going to be the absolute value of negative 1 equals 1, so 1 is equal to 1. So both of these in this case work. If one of them didn't work, you would go beside like your work and you would write extraneous, okay? That's what you would do if that were to happen, so to show that you checked it. All right, let's look at another one like that. Let's do 38. So this one, we have the absolute value of 9 minus 2x equals 10 plus 3x. So something to note with this one, okay, you're still going to be doing one of where you just copy the problem down. So you're still going to have your 9 minus 2x equals 10 plus 3x. But your other one now, when you have the right side being negative, just keep in mind that with there being two pieces, the negative sign has to go on both. So it's going to be 9 minus 2x equals negative 10 minus 3x. Okay, another way you could do it is to do negative and then parentheses 10 plus 3x. But if you just go ahead and put it through, then you don't have to like go through and distribute and stuff. All right, so left side, what do I do? Or like the left one. So that's going to be negative 5x. And I can go ahead and do the numbers in the same step. So that's going to be equal to 1, right? So then I have x is equal to negative 1/5. And then on the right side, what do I have over there?
X equals negative 19.
All right, so I'm going to check them. Obviously, fractions aren't fun, but unfortunately we have fractions. So we're going to check it. So we have the absolute value of 9 minus 2 times negative 1/5 equals 10 plus 3 times negative 1/5. So 19 plus 2 over 5 equals 10 minus 3 over 5. And remember, you have to just work your way down the left side and work your way down the right side. Don't like start moving stuff around. Leave it where it is. So I need to get a common denominator. So 19 times 5 is 95.
Where did you get the 19?
Yeah, shouldn't it be the other?
Shouldn't it just be 9?
Yes. I'm looking up here in this. I'm like, oh, it's a 19.
Well, now you've got you rid of the absolute value.
I just need to make, hold on. We're just going to do it a different color because clearly it's just confusing. Okay. There. Okay. I'm going to give y'all a cookie point. Since apparently I just can't read. Okay, so 5 times 9 then is 45, so 45 over 5 plus 2 over 5 equals, I'm going to do the same thing over here, put the 10 over 5, so it's 50 minus 3 over 5. So I've got 47 over 5 equals 47 over 5. And I'm just going to save a step and not write the absolute value again.
Can I have it as 9 2/5?
No. Told you, no mixed numbers. All right, then the other one, actually write it as absolute value this time. 9 minus 2 times negative 19 equals 10 plus 3 times negative 19. So what does that give me in the absolute value on the left?
9 plus 38.
And what do I have on the right?
Negative 10 plus 38. With only 7. Negative 10 plus 10 minus 57. Still be 38, right? It's times 3 that time. Oh. I didn't see that.
When she said negative 10, I was like, man, I wrote it wrong again. And then I was like, oh, wait, no, the original didn't have negative. All right, so then what does the left give me?
47.
47, and it's positive, so I can get rid of the absolute value. What does the left side give me?
Negative. Wait, you just
What
said
is-
left side.
Right side.
The
Or-
Negative
48
47.
be negative? Because we had negative up there.
No, that's
Negative
not the original.
Going into the
problem.
original.
Oh, okay.
Yeah, that's where it gets confusing. It's always hard to remember, like, wait, the original. So 47 equal to negative 47, is that true?
No.
So then this one is extraneous. So our only real solution is this one. All right, any questions about the equality ones? All right, so we'll do a couple of the inequality ones. Again, they say to graph, but we're not going to do that. So 46, we have the absolute value of n minus 11 is greater than or equal to 1. So the only difference with these ones, okay, you still do the same thing where you copy it down exactly, and then the other one you're going to change the sign. But when you change the sign, like positive or negative, you've also got to flip the inequality over. So this one would be n minus 11 is greater than or equal to 1, or n minus 11 is less than or equal to negative 1. So when you do it, think about like how when you divide or multiply by a negative, it flips the radical. So that's the same thing that's happening here. So I would have n is greater than or equal to 12. And on the other one, I would have n is less than or equal to 10. And that's all you have to do for those ones. The other one, 48. The absolute value of f plus 6 is less than 2. So what are the two different ones that I have set up here?
F plus 6 is less than 2, and F plus 6 is greater than negative 2.
Okay, and just backing up a second. N was greater than or equal to 12, or n was less than 10. Okay, so those were going opposite directions if you were to graph them, so that's why we leave them separate. If it were to be going in the same direction or like pointing together, then we would write them all as one. So, all right, so then what do we get here for the one on the left?
Or F is less than negative 4.
Yep, f is less than negative 4, and how about the other one?
F is greater than negative 8.
Is greater than negative 8. So if f is less than negative 4 but greater than negative 8, is that going toward each other or away from each other? If it's less than negative 4, okay, it's going this side of negative 4, and it's greater than negative 8. They're going toward each other. So we would do negative 8 less than f less than negative 4. Any questions about any of those ones? Okay with those? Alright, so your problems are, you have about 25 minutes to work on them. 9, 17, 25, 35, 37, 45, and 55. So not too many. And remember, you do not need to graph them. And you only need to check for extraneous solutions on the ones that specifically say to check for it.